Today's lesson is on taking a parabola in general form or standard form into vertex form using a method called completing the square. You saw this lesson, or you saw this method, completing the square, in the last lesson. Today we're going to deal with parabolas that have a stretch, a shrink, or a flip factor on the front end. Here's our first example. This is a parabola with a stretch factor of 4, and our goal is to put this into vertex form so that we can easily identify the vertex and the line of symmetry. The first thing we're going to do, which is similar to the last lesson, is we're going to regroup this so that the A term and the B term are together, but the C is removed because we can tell that 17 is not a perfect square, so we know we need a different number there to complete that perfect square. The next step is to divide out or factor out the leading coefficient from the A and the B. And worth noting at this point is our equation is still equivalent to the original. We've just regrouped and moved some things around. Now, what we'd like to do is we would like to add a term inside the parentheses that makes the x squared plus 4x a perfect square. Half of 4 is 2, 2 squared is 4, so 4 is the number that completes the square inside the parentheses. Now, we have thrown this equation out of balance by adding 4. We have actually not only added 4, we have added 16. So we are going to subtract 16 to offset the fact that we've added 4 times 4. Our last step then is to write this as the square of x plus 2. 17 minus 16 is plus 1. This is vertex form for this parabola. Its vertex is negative 2, 1. Since the parabola is right side up with a stretch factor of 4, the vertex is a minimum value. The domain is all real numbers, and the range is values that go from 1 to infinity. Here is the algebra tiles demonstration of the exact same problem. You see here that the equation 4x squared plus 16x plus 17 is what we started with. You'll notice 4 times we have squared x plus 2, and there is 1 tile left over at the end. Here's our second example. We'll follow the same process we used before. We will take the A term and the B term, put it together inside parentheses, and move the C regrouped to the outside. That is a 94. We'll divide out the leading coefficient. In this case, that's negative 1. That's x squared minus 20x minus 94. And we will now complete the square. The number that goes here is the half of the B term squared. So this is going to be plus 100. We've added 100 on the inside, which means we've actually added negative 100 because of that distributive property. So we're going to add 100 to offset that subtraction. And our vertex form then is y equals negative 1, x minus 10, quantity squared, plus 6. The vertex is 10, 6. That vertex is a maximum point because of the negative 1 has flipped it upside down. Its domain is all real numbers, and its range is negative infinity all the way up to the y-coordinate of the vertex, which is 6. Here's example 3. We'll follow the same method. We will put 3x squared minus 24x inside parentheses. We'll remove the C term. We will factor out the leading coefficient. And again, worth noting that these two are still equivalent. We've just done some regrouping. We will add inside to make this a perfect square. Half of negative 8 is negative 4. Negative 4 squared is 16. That makes that a perfect square. Since we've added 16, we've actually added 16 times 3. So to offset that, we're going to subtract 16 times 3. And let's do a little mental math here. 3 times 16, 3 times 6 is 18, so that's got to be 48. And then our vertex form is y equals 3 times the quantity x minus 4 squared minus 8. That vertex is the point 4, negative 8. That vertex is a minimum point because of the positive a value. The domain is all real numbers. And the range is negative 8 to infinity. Your homework tonight is a completing the square Schoology quiz for a not equal to 1. Please pay attention to when it asks you to write an equation. When you need to write an equation, you must start your vertex form with a y equals. And in a Schoology quiz, the squared is represented by the caret, and then you'll do your plus or minus k at the end.